Hi there, this is Penelope and my dog Sylvie. You probably hear her barking as well. This is a short video on how to expand sine 3 theta. And sometimes you're given clues of how to expand it, sometimes you're just not. So right now, let's go without any clues. Let's just go for expanding it. Okay, so I've added in a little bit of a clue, but not much. But what we need to know is, again, this is something that we can use a trig identity for. Have a look at this. We can write sine 3 theta as sine 2 theta plus theta. Now, that is an example of sine A plus B, which we can expand to being sine A cos B plus cos A sine B. No, actually, let's rewrite that. So sine A cos B, and then it should be sine B cos A. Sorry about that. Okay, let's go back then and put this into context. That's just the rule. So now we have sine 2 theta cos theta plus sine theta cos 2 theta. Now, that's not terribly helpful just yet, but if we use a couple of other trig identities, I'll write them over here. If we use that sine 2 theta is equal to 2 sine theta cos theta, that's one we're going to use. And then the other one that we're going to use is to deal with the cos 2 theta, which is 1 minus 2 sine squared theta. So we're going to use those. They're on your formula sheet, in a textbook, wherever. So instead of sine 2 theta, we're going to write 2 sine theta cos theta. But we already did have cos theta. Plus sine theta times 1 minus 2 sine squared theta. Okay, let's tidy that up. So what we've got in the first term is 2 sine theta cos squared theta plus, let's expand our brackets since we've got them, minus 2 sine cubed theta. Now it does just say to express it in terms of sine theta, so I think we've got a little bit more work to do. We've got another very basic trig identity that says cos squared theta equals 1 minus sine squared theta, or actually what it does say is that sine squared theta plus cos squared theta equals 1. So we're going to use that to write our first term. So then we've got 2 sine theta times 1 minus sine squared theta so now we've got 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. Okay, collecting them all up, we have 2 sine theta plus sine theta, that's 3 sine theta, minus 2 sine cubed minus 2 sine cubed, so that must be minus 4 sine cubed theta. So that's one way of doing it, and that's avoiding any reference at all to complex numbers. Now, normally there's no prescribed way to do anything. So let's have a look at it if we are going to find sine 3 theta in terms of sine theta when we use complex numbers. Okay, one of the big rules that you would have would be that cos n theta plus j sine n theta is equal to cos theta plus j sine theta to the power of n. Now in this case, this example, what we're looking at is cos 3 theta. So what we really want on the right hand side is, well, let's just write cos theta plus j sine theta cubed, and on the left hand side we're going to write cos 3 theta plus j sine 3 theta. Okay, this is all that we need, right? So we've got to work it all out and then look for the term that's attached to j. Okay, let's expand that. Let's expand the right hand side. So we've got cos cubed theta plus, I'm just using Pascal's triangle to make it quicker, 3 cos squared theta j sine theta plus 3 cos theta j sine theta squared plus the last term, which would be j, j sine theta cubed. Okay, let's just, we'll probably go to the next step. We know that j squared equals -1 and that j cubed equals -j. So just remember that. Now, what we've got is we've got to just find the j term. So we're comparing the j terms. So we've got j sine 3 theta. Okay, so we've got j times 3 cos squared theta sine theta. And then from this term, the j disappears because j squared is -1, so that's gone. So we only have to deal with the last term, which would be minus, it would be plus j cubed, which is the same as minus j sine cubed theta. Okay, so now we're looking, we've got all the j terms, we've got all the things, so we can just ignore the j for the moment. Clearly we haven't got the same answer as we did before, but let's make one of those basic substitutions that cos squared is equal to 1 minus sine squared. So that gives us 3 sine theta minus 3 sine cubed theta minus sine cubed theta. Hey, we've now got the same as we had before. Like that, and we're done. So we've proved what we needed to prove. It got it exactly the same as we did before. So there's two different ways of doing the same question, of coming to the same answer. Half a dozen, 1/6 of the other, as they would say. They're both as easy or as not easy as the others. Okay, thanks for watching.